In-class activity 14C. 1. For a given value of x, which do you think is bigger, x to the 1/2, to the 1/4, or the 1/6? Well, the answer is going to depend on how large x is. If x is in the interval 0 to 1, then x to the 1/2 is going to be less than x to the 1/4, which is less than x to the 1, that's supposed to be 1/6, 1/6. If x is equal to 0 or 1, then the values will be the same. And then for x greater than 1, it's going to turn around. X to the 1/6 will be the smallest. X to the 1/4 is next. And then the largest would be x to the 1/2. Objectives for the activity. You will understand how the shape of the graph of y equals x to the p over q is directly related to the properties of p and q. You will be able to identify and describe properties of a graph, such as increasing or decreasing, or opening upward or downward, using intervals in the domain. 2. Use a graphing calculator or app to graph the following functions on the same set of axes: y equals x to the 1/2, x to the 1/4, or x to the 1/6. If we go to our calculator app here, I'm going to go to the y equals screen, and I have some of this in here already. Let me just clear this out. And we're going to use x, and we're going to go x to the 1/2 first. And let's graph this and see what we get. All right, so that looks good. And let's do another one. Y equals screen, we'll do x to the 1 divided by 4. And graph. We see a second curve there. And then we'll do this once more. Y is equal to, whoops, let's go back and down here we go. X to the 1. This is not working out here. Come on, there you go. X to the 1 divided by 4. 6. Graph. So there we see the three curves. Let's go back to our paper and write this out here. Part A says sketch the graph and label each curve. Well, each of these curves, they're going to go through the 2 points 0, 0, and 1, 1. The first curve we graphed was y equals x to the 1/2. It's going to come up like this, go through the point 1, 1, and then go out here. And we'll label that x to the 1/2. There we go. The second curve, x to the 1/4, is going to start at the origin. It's going to be a little bit higher between 0 and 1 than the previous curve. And then switch, it's going to go underneath of x to the 1/2. And then our last curve, again, starts at the origin, goes a little bit higher in the interval 0 to 1, and then y is equal to x to the 1/6. So it'll be underneath the other two curves. Part B, what patterns do you see for the domains of these functions? All the functions have domains 0 to infinity. Let's go to part C, which is next. It's on the next screen. So I'm going to scroll up here. It says, what patterns do you see for the ranges of these functions? These functions also have the range 0 to infinity. Part D, in question 1, you compared x to the 1/2, x to the 1/4, and x to the 1/6 for a given value of x. How does the graph shown help you make that comparison? Well, from the graph, we see that from the position of the curves, that when x is in the interval between 0 and 1, I'm just going to scroll back up to the graph so we can look at it. X is the smallest, with x to the 1/2 is the smallest, and x to the 1/6 the largest. And all of the curves intersect at the points 0, 0, and 1, 1. And then when x is in the interval greater than or equal to 1, we have x to the 1/6 being the smallest, and x to the 1/2 being the largest. Okay, let's go to part E. Part E, there, I passed it. It says, using the graph and the given information so far, what do you think the graph of y to the 1/8 looks like? Make a sketch on the same grid we used at question 2. So I'm going to go back up here, and I'm thinking we're going to start at the origin. In between, in the interval 0 to 1, we're going to be a little bit higher than our other curves. And then when we pass through the 0.11, then we're going to be the lowest curve. So it looks something like that. Go back to where we were. Let's go back to part F now. Part F, it says let y equals x to the 1 over q, where q is a positive even number. What can you say about the domain and range of the graph of this curve? Describe how the shape of the graph changes as q increases. Use different intervals in the domain to compare graphs. Okay. Well, we could say the domain and range for this are both 0 to infinity. In terms of the shape of the graph, as q increases, the shape of the graph changes, and well, the graph begins to, you could say, flatten out. And the graph is increasing on its domain, and it's also opening downward on its domain. And all curves are going to go through the points 0, 0, and 1, 1. And for the interval between 0 and 1, x to the 1/2 is going to be smaller than the other values. And for the interval greater than 1, x to the 1/2 is going to be the larger of the values. Part 3, use a graphing calculator or app to graph the following functions on the same set of axes. Y is equal to x to the 1/3, y is equal to x to the 1/5, y is equal to x to the 1/7. Part A, we want to sketch the graph and label each curve. So let's go ahead and graph this. Let me go back here, and we're going to clear out what we have so far. And now we're going to graph x to the 1/3 power. And let's just graph it, see what it looks like. Okay, so we'll do another one of these. How about, well, x is equal to, or y is equal to x to the 1/5 power. And we'll do x raised to the 1/7. And then we have our 3 curves. Now let's go ahead and go back to where we were. I'm going to move this up to the top here. And if we think about what we had, all curves go through the origin. They go through the point 1, 1 and the point -1, -1. If we graph x to the 1/3 or sketch that in, we're going to start here, go through the point 1, 1, and then go up here. So this is y is equal to x to the 1/3. Then going in the negative direction, I'm going to go through the point from 0, 0 to -1, -1, and then go down like that. For x to the 1/5, we'll start at the origin. We'll be a little bit above the curve in the first interval there, and then we'll switch and we'll go underneath of the 1/3. So that's x to the 1/5. We'll do the same thing going in the other direction. And then x to the 1/7 power are going to be the highest so far, and then the lowest. There we go. What patterns do you see? This is part B. What patterns do you see for the domains of these functions? Well, all the functions have a domain of all real numbers, so -infinity to infinity. And well, we can take the cube roots of negative numbers. We can also take the 5th roots and the 7th roots of negative numbers. That's why we see the negative parts of the graph here when we graph it in the picture above, or the graph above. Part C, what patterns do you see for the ranges of these functions? Well, all the ranges are all real numbers, and I'll use interval notation again to write that -infinity to infinity. Part D, I'm going to just scroll this up here. Given a value for x, how would you compare x to the 1/3, x to the 1/5, and x to the 1/7? And then use different intervals in the domain to make that comparison. Okay, let's do this. For the interval, We'll do negative infinity to negative 1, and then we'll go negative 1 to 0, and then we'll go 0 to 1, and then 1 to infinity. And then our comparison so when we have x in the interval, the first interval, negative infinity to negative 1, x to the 1/3 will be the smallest, then x to the 1/5, then x to the 1/7, the largest. Now, between negative 1 and 0, it's going to switch. We're going to have x to the 1/7 be the smallest, and x to the 1/3 be the largest. In the interval 0 to 1, x to the 1/3 is going to be the smallest, x to the 1/5 the largest, and x to the 1/7 the largest. I'm sorry. X to the 1/7 is the largest. And then for the last interval, 1 through infinity, and we switch again. X to the 1/7 is the smallest, with x to the 1/3 being the largest. Part E, using the graph and the given information so far, what do you think the graph of y equals x to the 1/9 looks like? And we're going to sketch this on the same grid that we did for question 3. So let me go back up to the graph here, and I think we're going to start at the origin. We're going to be above all the curves in the first interval to the right of the origin, so between 0 and 1. And then once we go through the point 1, 1, we're going to be the lowest graph. So that's equal, y is equal to x to the 1/9. And then going in the other direction, we're going to do the same kind of pattern, and then we're going to end up above the other curves. Let's go to part F here. Where did it go? Way down here. There we go. It says let y be equal to x to the 1/q, where q is a positive odd integer. What can you say about the domain and range of the graph of y equals x equals 1 over, or x to the 1/q? We want to describe the shape of the graph and the changes and the different intervals. So we could say the domain and the range, they are both all real numbers. So the domain, okay, and the range, oops, there we go, all real numbers. And the graph is increasing in its entire domain, increasing. And the graph opens upward. So it opens up on the interval negative infinity to 0, and then it opens down on 0 to infinity. As q increases, the shape of the graph changes and it begins to flatten out. We said that earlier, and all graphs will pass through the points -1, -1, 0, 0, and 1, 1. The relationships among the graphs that were noted in part C will continue to hold. Let's go to part 4. Part 4, I'm just going to scroll up here. It says let y equal x to the p/q, where p and q are positive integers, and the fraction p/q we're assuming is in lowest terms. So part A says explain why these are the only 3 options for p and q. Let's see, we have p is odd and q is even. Then we have both p and q both odd, and then p is even and q is odd. Let's see what's going on. Oh, you might think, why can't we have both p and q are both odd, but why can't they be, or don't they have p and q being both even listed here? And well, we're assuming the fractions in lowest terms. So if p and q are both even, then there will be a factor of 2 common to both of those, and then it wouldn't be in lowest terms anymore. So these are the only 3 possibility, where 1 is odd and 1 is even, or both are odd. So let's go ahead to part B. I'm just going to scroll up here. So part B, it says, if p is odd and q is even, what can you say about the graph of y equals x to the p/q? Describe the domain and range, as well as intervals over which the function is increasing or decreasing. Okay, so in this case, the domain is going to be 0 to infinity, and the range is also 0 to infinity. And the graph's going to go through the points, it's going to go through the origin, it's going to go through 1, 1, and the function we can say is increasing on its domain. Part C, if P is odd and Q is odd, what can you say about the graph? Okay, well, in this case, the domain is going to be all real numbers. And, the range is also going to be all real numbers. I'm using interval notation for those there. And the function increases. It's going to be increasing on its entire domain. And the graph is going to go through the points, -1, -1, the origin, and again 1, 1. Part D, now we have P is even and Q is odd. What can we say? In this case, let's see, even and odd, the domain is, let's see, in this case, the domain, what happened there? Let me fix it. There we go. The domain is all real numbers, and the range is going to be, oops, let's do a different end bracket there, 0 to infinity. The graph decreases on the interval, -infinity to 0, and has a minimum at the origin, and it's going to be increasing. Oops, there we go, increasing 0 to infinity. The graph's going to go through the points, -1, 1, 0, 0, and 1, 1. Okay, that's the end of this video. Thank you.